Alright, we're in the Helicopter Flying Handbook. This will be Chapter 9, page 10 of 20, Crosswind Considerations during Takeoff. If the takeoff is made during crosswind conditions, the helicopter is flown in a slip during the early stages of the maneuver. The cyclic is held into the wind in sufficient amount to maintain the desired ground track for the takeoff. The heading is maintained with the use of anti-torque pedals. In other words, the rotor is tilted into the wind so that the sideward movement of the helicopter is just enough to counteract the crosswind effect. To prevent the nose from turning in the direction of the rotor tilt, it is necessary to increase the anti-torque pedal pressure on the side opposite the cyclic. After approximately 50 feet of altitude is gained, make crosswind considerations during takeoff. After approximately 50 feet of altitude is gained, make a coordinated turn into the wind and maintain the desired ground track. This is called crabbing into the wind. The stronger the crosswind, the more the helicopter has to be turned into wind to make the desired ground track. Straight and level flight. Straight and level flight is flight in which constant altitude and heading are maintained. The attitude of the rotor disc relative to the horizon determines the airspeed. The horizontal stabilizer design determines the helicopter's attitude when stabilized in airspeed and altitude. Altitude is primarily controlled by the use of the collective technique. To maintain forward flight, the rotor tip path plane must be tilted forward to obtain the necessary horizontal thrust component from the main rotor. By doing this, it causes the nose of the helicopter to lower, which in turn will cause the airspeed to increase. In order to counteract this, the pilot must find the correct power setting to maintain level flight by adjusting collective. The horizontal stabilizer aids in trimming the helicopter longitudinally and reduces the amount of nose tuck that would occur. On several helicopters, it is designed as a negative lift airfoil, which produces a lifting force in a downward direction. Figure 9, 10. Let's look at these figures before we go in. So we already did the crosswind considerations during takeoff, helicopter side movement, wind movement. To compensate for wind drift at altitude, crab the helicopter into the wind. Yep. Okay, so now we're going to do this. Figure 9-10. Maintain straight and level flight by adjusting the rotor tip path plane forward, but adjusting collective as necessary to maintain a constant airspeed altitude. The natural horizon line can be used as an aid in maintaining straight and level flight. If the horizon line begins to rise, slight power may be required or nose of the helicopter may be too low. If the horizon line is slowly dropping, some power may need to be taken out or the nose of the helicopter may be too high, requiring cyclic adjustment. All right. So while in straight and level flight, any increase in the collective while holding airspeed constant causes the helicopter to climb. A decrease in the collective while holding airspeed constant causes the helicopter to descend. A change in the collective requires a coordinated change of the throttle to maintain a constant RPM. Additionally, the anti-torque pedals need to keep the helicopter in trim around the vertical axis. To increase airspeed and straight and level flight, apply forward pressure on the cyclic and raise the collective as necessary to maintain altitude. To decrease airspeed, apply rearward pressure on the cyclic and lower the collective as necessary to maintain altitude. Although the cyclic is sensitive, there is a slight delay in control reaction, and it is necessary to anticipate actual movement of the helicopter. When making cyclic inputs to control the altitude of airspeed of a helicopter, take care not to over-control. If the nose of the helicopter rises above the level flight attitude, apply forward pressure to the cyclic to bring the nose down. If the correction is held too long, the nose drops too low. Since the helicopter continues to change attitude momentarily after the controls reach neutral, return the cyclic to neutral slightly before the desired attitude is reached. The principle holds true for any cyclic input. So, since helicopters are not very stable but are inherently very controllable, if a gust or turbulence causes the nose to drop, the nose tends to continue to drop instead of returning to a straight and level attitude as it would on a fixed-wing aircraft. Therefore, a pilot must remain alert and fly the helicopter at all times. Common errors. Failures to trim the helicopter properly, tending to hold anti-torque pedal pressure in opposite cyclic. This is commonly called cross-controlling. Failure to maintain desired airspeed. Failure to hold proper control position to maintain desired ground track. Failure to allow helicopter to stabilize at new airspeed. What are we at? 5. So turns. A turn is a maneuver used to change the heading of the helicopter. The aerodynamics of a turn were previously discussed in Chapter 3. Aerodynamics of flight. Technique. Before beginning any turn, the area in the direction of the turn must be cleared not only at the helicopter's altitude, but also above and below. To enter a turn from straight and level flight, apply sideward pressure on the cyclic in the direction of the turn is to be made. This is the only control movement needed to start the turn. Do not use the pedals to assist the turn. Use the pedals only to compensate for torque to keep the helicopter in trim around the vertical axis. Keeping the fuselage in the correct streamlined position around the vertical axis facilitates the helicopter flying forward with the least drag. Trim is indicated by a yaw string in the center or centered ball on a turn and slip indicator. During a level and coordinated turn, the rate of turn is commensurate with the angle of bank used, and inertia and horizontal component of the lift, the ACO, are equal. How fast a helicopter banks depends on how much lateral cyclic pressure is applied. How far the helicopter banks, the steepness of the bank depends on how long the cyclic is displaced. After establishing the proper bank angle, return the cyclic toward the neutral position. When the bank is established, returning the cyclic to neutral or holding it inclined relative to the horizon will maintain the helicopter at the bank angle. Increase the collective and throttle to maintain altitude and RPM. As the torque increases, increase the proper anti-torque pedal pressure to maintain longitudinal trim. Depending on the degree of bank, additional forward cyclic pressure may be required to maintain airspeed. Rolling out of the turn to straight and level flight is the same as the entry into a turn, except the pressure on the cyclic is applied in the opposite direction. Since the helicopter continues to turn as long as there is any bank, start the rollout before reaching the desired heading. The discussion on level turns is equally applicable to making turns while climbing or descending. The only difference is that the helicopter is in the climbing or descending attitude rather than that of level flight. If simultaneous entry is desired, merely combine the technique of both maneuvers, climb or descent entry and turn entry. When recovering from climbing or descent turn, the desired heading and altitude may rarely reach at the same time. If the heading is reached first, stop the turn and maintain the climb or descent until reaching the desired altitude. On the other hand, if the attitude is reached first, establish the level flight and attitude and continue the turn to the desired heading. All right, we're going to hold off there. Holding off there at page, about page 12 of 20. That was just turns. We did straight and level flight and turns and crosswind considerations. Right, next will be slips on page 12 of 20 in chapter 9. See ya.